We're nice.
Taylor, what'd you get for the first one on the warm-up? Very good. You guys agree with her?
Yeah.
You should. She's right. Just add our exponents. All right, Mr. Collins, what'd you get for number 3? 1/2, right? What about the e's?
So 1 over 7.
Was the higher exponent for the e top or bottom?
Bottom 3, 1/2.
Right. This e would be in the bottom. You guys okay with that?
Yeah.
Why not?
I don't know how to do any of it.
That's just old stuff. Yeah. Stuff that we know how to do already, right? Just when you have bases with the same, or you have exponents with the same base, you just subtract wherever the higher exponent is, stays in that area. So the higher exponent was 10, so the e stayed in the bottom, and then 11/22, this is 1/2, right? 11 goes into both. All right, Sophia, what's 5⁴? Good. What do I do with the 7x in the 4th? Yeah, so that's what, 28x? All right, just rules of exponents that you've had before. So the 5⁴ was the 625, and then e to the 7x raised to the 4th power, and just goes 7x times 4. Now, what did we say to do with this square root yesterday? Write it as a what? What exponent? What exponent is square root? No, 1/2, yeah. If it was cube root, we use 1/3, right? So, what is 9 to the 1/2, or the square root of 9? 3. And then just multiply these. What's 6x times 1/2? 3x, right. So that makes it easier when you change it to 1/2 there. Then you can multiply the 6x times the 1/2 for our exponents. And then 9 to the 1/2 is like the square root of 9. All right? So, any questions on 2 through 10? You want me to give you the answers to those? I can. Number 2 is e squared. Number 4 was 9e to the 3rd. Number 6 was 64 over e to the 6x. Number 8 was 2e to the 4x. And number 10, we had to do 10, didn't we? E to the 2x plus 7. So you just combine like terms here, just add. X plus x was 2x, 4 plus 3 was 7. Since they are all the same base, just add the exponent. Okay? We good on that set? Okay. And then we did 13, 14, 15, 16, right? So I would just put in my calculator e to the 2x and see which one it matched up with. 13 matches with D. 14 matches up with A. And again, that's a growth because the exponent's positive. All right, so it's one of these two. It was D. And this is decay because it was negative exponent, and it ended up being A. So 15's decay because it's negative, so that should be B. And 16, we got a positive exponent, so that's growth. That would be C then. Okay? But I would just put in my calculator and match them up. Then we jumped down to what? After that one? 33 and 34, that was it? Oh, it's right here, right? I thought we had these.
Oh.
Yeah, it does, right? Is this growth or decay? 18. Decay. 20, 22, 24. Growth, right? We're just looking, when it's the E, the natural base, all right, then E, we look at the exponents for growth and decay. Positive exponent growth, negative exponent decay. If I want you to graph them, which I'm not going to really worry about it, you just put in your calculator, okay? All right, then 33 and 34, we're using that continuous, well, for 33 we are. We're doing that continuous compounding continuously, which was the principal times e to the r times t power. That was, and that's what they've got here for the balance A in dollars of the house account after 2 years can be modeled by this equation. The graph shows the balance of the account over time. Which account has a greater principal, okay? So, this principal was $3,224. What was this principal? $4,856, right? So, this one had the higher principal, right? It said, which account has greater, we just said that, which account has a greater balance after 12 years? So, we have to use T12, right, to figure this one out. So 3224 e to the 0.05, what would be 5%, would be our rate, interest rate, times 12. What'd that equal? Anybody got that written down? Nobody wrote it down? Okay. And I'll do it. So 3224 E. How do I get that to pop up? Second ln, right, that natural log. We'll start talking about logs today, actually, logarithms. All right, to the 0.05 times 12. Remember, we're multiplying those two together. R times T, 0.05 T means times T, all right? So that was $5,874.51. All right, and then here, your 12 would be up here to here, and then over, almost $8,000. So this had the bigger principal, and it also had the bigger amount after 12 years. You guys understand how to read the graph? Okay. Good. All right, 34. It says tritium and sodium-22 decay over time. In a sample of tritium, the amount Y in milligrams remaining after T years is given by this equation. The graph shows the amount of sodium-22 remaining in a sample over time. Which sample has a greater initial amount? All right, well, these are going by 5, so that's 5, 10, so that's 15 it started at. And this started at what? What's that number in front of E? 10. So this had the sodium-22 started with the greater initial amount. Which sample has a greater amount remaining after 5 years? So I have to put 5 in here for T for that one. So 10E to the negative 0.0562 times, what was it, 5, right? So let's see what that equals. Just put that in our calculator. All right. 10, again, e to a power is second natural log. And then we've got a negative 0.0562 times 5. So that was 7.55. After 5 years here, here's 5 years, it's going by fives, it looks like. There's where it's at, and that's a 5 there. So that's less than 5, 4 something. So the tritium would have more after 5 years. That make sense? Okay. All right, any questions on that? Pretty easy stuff, right? Basically, from that section on your quiz Friday will be like those two problems. The rest of it was pretty easy stuff that we've already done. So the rest of your quiz on Friday will be over this stuff. Logarithms, okay? So, you know, it says 2 squared is 4 and 2 cubed is 8. However, for what value of x does 2 to some power equal 6? It says mathematicians define this x value using a logarithm and write x equals log base 2 of 6. So they changed this problem. We call that in exponential form, and we call this logarithmic. So the definition of a logarithm can be generated as follows. So here's the definition of a logarithm. It says let b and y be positive real numbers, and b will not be equal to 0. So b is our base, okay? Base of our problem, right, Wolf? And it's not going to be 1, but it's going to be positive. And it says the logarithm of y with base b is denoted as log base b of y. That's how we say that, log base b of y. All right? And log base b of y equals x is the logarithmic equation, and it's equal to the exponential equation b to the x equals y. All right? So you have to be able to write a log problem as an exponential and an exponential as a log. So you need to know that this you can rewrite like this. Okay? And if I give you this in exponential, you should be able to write it like that. That's what you should be able to do. So you should probably write that down in your notes if you don't already have it. Okay? If you learn this today, you'll be fine. It's really easy once we practice. Okay? So if I have, again, you might need me to do that. You might need to see that still. All right? So if I write 2 squared, you guys all know 2 squared equals what? 4, right? In logarithmic form, you go log, what's the base? 2. So log base 2. We call that a subscript when we write it as a little number down below right. When it's a little number above right, we call it an exponent, right? Of the number is 4, equals the exponent 2. That's what logarithms are. They're exponents. All right? So if you guys know that, let's say 3 cubed is 3 times 3 times 3, that's 27, right? So in logarithmic form, you go log, what's the base? 3 of the number equals the exponent 3. Logs equal exponents. Okay? So if I write log base 4 of 16 equals 2, I know that to be a true statement. What's the exponential problem?
2 exponent of 4.
Close.
4.
Yeah. This is the base. That's the exponent equals the number. So that's 4 squared is 16. Okay? You following me? All right, so if I did log base 1/2 of 4 equals -2, what's the exponential form of that? Emma?
Half as the
Good,
-2.
good. Awesome, that is correct. You guys getting this?
Yeah.
So far, so good? Okay. Mr. Geyer, what's that one? No.
2 to the 4th, 16.
There you go.
Hey!
2 is the base, 4 is the exponent, equals the number 16. Brooke, this one.
Basically 4. Exponent would be 0.
Right, and that's always going to be true. Anything to the 0 power is what? 1. Right, so whenever, like you might get a problem tonight that'll say log base 4 of 1. You know, you're supposed to evaluate that, figure it out. Anytime that number is a 1, no matter what the base is, what's the answer going to be? 0. Okay? And we're going to talk about that here in a minute anyway. AJ? Good.
You're so smart.
Okay? Whenever the base and the number are the same, the answer is always going to be what? Always going to be 1. They like cancel each other out. Okay? So those are little quick ones. Caitlin?
1 to the -1.
Good. That is correct. So far, so good? All right. Do we have any more down here? No? All right, going the other way. Mason, what's this in log form? What's the base of my log?
5.
Yeah. What's the number? What's the exponent? Yeah, there it is. All right? So remember, that's your base. So it's log base 5. That's your number of 25 equals the exponent, because that's what logs are. They're the exponents. No comment? Got this, don't you? Spencer, what's that in log form?
Log to the 10,
Log base 10, we say. Yeah.
-1, 0.1 equals -1.
Very good. Questions? We with it? Okay. Sydney?
It'll be log 4. No,
What's the base?
I don't know. I
We'll look at the problem. Which one's the base? Is 4 the base or 8 the base? Yes. Of the number equals the exponent 2/3. So this was tricky. Why? They just switched the order on you, right? Most of the time we've had it on the left, right? This time we had the base and the exponent on the right. So don't let that mess with you. Okay? Collins? Whoa.
Whoa. We got log. 6,
Base 6, right?
and then 1 over 260
Yep.
equals -3.
Good. So far, so good. You guys are awesome. All right. I don't think there's an E for this one either. All right. So I just talked about these. Whenever this number is a 1, the answer is always going to be what? 0. Whenever the base and this number are the same, the answer is always going to be 1. Okay? So when I see that, I kind of just do this, like cancel them out. Okay? Those are special ones. All right? All right, so it says evaluate this. No calculator needed. All right, so when I do these, I always write equals X. You won't see it in the problem, but I write equals X. And then I rewrite it as an exponential. So William, what is this in exponential form? What's the base of my log? Right. Logs equal exponents. So what's my exponent? Equals whatever number's there. 16. All right. So most of you can do this in your head. What you want to do in these without a calculator is try to rewrite both sides with the same base. Can I write that as a base of 4? 16 is 4 to what power? Second. So what's X equal? 2. That's how you do it without a calculator. So you say equals X, so you can write it this way, and then you try to write both sides with the same base. And then whatever the two exponents are, you can set them equal. Since that exponent's X and that's 2, I can say X equals 2. If this was a 2X, let's say, then I can say 2X equals 2 and then solve for X. Sometimes that might happen. All right. So I'm going to write equals what?
X.
X. So then what is that in exponential form? Tristan?
Would be 125, or no, 5 X equals 125.
Right. Can we write 125 with a base of 5? Yeah, 5 to the what? Well, if you're not sure, just do this. 5 times 5 times 5. So how many times did I do it? 3. So this is 5 to the third. So what's X equal? 3. So this log is 3. Okay? So what do? Equals X. Sorry, I forgot that. I'm getting ahead of myself. So what's that exponentially, Brock?
5 to the X equals 1/5.
All right. So how do I write 1/5 with a base of 5? Yeah, the reciprocal. What kind of exponent makes me do the reciprocal? Yeah. So 5 to the, this is like 1 over 5 to the first, right? So this is 5 to the -1. So what's my answer? Right, Mason? Right, Mason?
I said,
I didn't hear you, sorry. My hearing's going bad. AJ, why you got a phone in your hand?
yeah, AJ. Okay, sit down. We're not done. We're not done. You don't speak math class.
See it, David.
5.
Hi, Taylor.
Okay,
Wow, that's.
so the fractions end up giving you negative exponents. Okay? All right, so what's my base now? 1/5. All right. So I like to use 5 as the base, right? So it's like 5 to the first. So what do I have to do? We just did it basically. That's like this, right? We just did this one. What's the 125 we just did on the calculator? That was 5 to the third, right?
What is negative 3?
So I got this negative. What's the rule here with this -1 in the end? Multiply, right? So like Caleb just said, the answer is -3. No calculators. Using this one. The one God gave you, right? You're allowed to use that one. I know some of you don't like to use that one, but you're allowed. Sophia, what's the exponential form? Okay, so this one looking a little tricky, isn't it? Okay. What is 0.125? It's a decimal. What's the proper way to say that? 125 thousandths, right. So, can we reduce that fraction? 1/8? Oh, did you hear Nolan? That reduces to 1/8. So can I write 1/8 with a base of 8? Yeah, what is it? 8 to the what? Negative first. Good. I'm going to go here because I want you to be able to see that still. Because remember, this is like 1/8 to the first, right? So if I want to move it up, I just change it to a negative. So what's my answer? -1. So if you get a decimal, I would write it as a fraction and then reduce it if possible. And then use your base. Try to get the same base, right? We got it to be a base of 8. How about this one? Remember, we always write equals x, right? So, Jordan, what is this in exponential form?
64 x 60.
Right. All right. So, what would be easier, to change this to 64 or the 64 to an 8 base? Which is what? 8 squared, right? And that's a 1, right? Well, what's the rule for these? Multiply them, right? So what's my equation to solve for x? 2x equals what? 1. So what's x equal? 1/2. Now let's think about this. What does 64 to the 1/2 power mean? What? Square root. Remember? Is the square root of 64 8?
Yeah.
It is, right?
Yeah.
See how that worked out? Making sense? What are these called? Logarithms, right? A logarithm is the exponent, right?
Homework.
Yeah, I think it's time for homework. Oh! One more thing.
We got
Oh, we got time. All right, so there's two different types of logarithms that are on your calculator. All right? We call the base 10 log the common log. When you see this, they won't write this on the left. They'll write it on the, like this on the right. So if you don't see a base, you know the base is what? 10. Right? You see the 10? When they don't write it, that means there's a 10 there. Okay? You won't see the log base E, you'll see ln, like on your calculator, the ln button, got the E to pop up. So when you see ln, the base is E, that natural one, okay? So when you get a couple of these problems, evaluate using technology, that means you can use your calculator. So go to your calculator, here's your log button, just go log of 8, close it up. So 0.903. Tough stuff, right? Again, since there was no base written, what was the base? 10. All right, here's ln. So you hit your ln button. 0.3, close it up. And then negative 1.204 to 3 decimal places, right? So you might have a couple problems where you're allowed to use technology means you can use your calculator. Okay? There you go.
Of what? Homework.
Yeah,
Of what?
you're gonna do it like always, right? Right, William?
I thought you were talking about the business. Are you okay?
Space and William Wolf, huh?
Yeah, I thought you
NWW.
Yeah.
You guys did good.